It's great to be here. It's great to see a former doctoral student as well here, and I look forward to any comments that you might have. Please let's let this be a dialogue. If whatever you'd like to ask questions. As Lepter's indicated, we're sort of looking at next generation supply chains, how they should be designed, and strategies for operationally running them. What I'll try to do with, in terms of an outline, is to give a little bit of a background on what a supply chain is. For those of you who may not have that familiarity, talk about energy implications, certainly, of course, because this is a energy center here. A lot of discussion about supply chain disruptions and how to deal with them. The importance of supply chain visibility meaning how the supply chain is currently working and running. Some next generation ideas on design and also ecosystem, not only the single supply chain, but the infrastructure that supports supply chains. Primarily, this is US focused. And that's the part of the port of Singapore right there. That's the 32 million PBUs port that we interact with regularly through the National University of Singapore. Okay, what does a company do or an enterprise? Often, and I'm thinking about a manufacturing company that makes things that we buy. Automobiles is an example. Usually, there's a lot of outsourcing and downsizing in manufacturing. It's a typical sort of thing. So an enterprise is not only the company, but also the suppliers for that company and how it distributes its goods. And basically, the idea is to make a product that people want to buy and make it a little less expensively than the competition, a little faster. And more recently, a little more predictable because of the uncertainties that have been cropping up in supply chains recently. What is a supply chain in the context of enterprise? It's flow of goods, stuff moving, of course, but there's a lot of flow of information in order to control and synchronize the flow of goods. So we'll be talking a lot about the flow of goods and to some extent the flow of information. There's also the flow of money, of course. We won't talk so much about that. But this is basically the enterprise itself and what a supply chain is. More specifically, we have suppliers making sub-assembly components for a product that gets sent to a manufacturer or an assembler that produces the final product that goes to distribution and then on to the customer. And there are a variety of ways of organizing the supply chain and controlling it. One way is mass production. This is sort of a standard way of building a supply chain, where we make a lot of it, enjoy economies of scale because we make so many of them. And it's a little bit of an old system that is typical of automotive and durable goods manufacturing. You end up with a lot of inventory. You don't have to have a particularly sophisticated information system or a transport system, but you make your money, make your profits from the fact that you're minimizing the cost per unit that's made. Another way is build to order, and this is mass specialization. This is adaptive. Very agile supply chains, and these are good kinds of ways of designing a supply chain if you have a lot of volatility in demand and you have to have your supply chain to adjust easily. This is a great supply chain strategy if you have a very smooth demand and it works very well. But this is kind of, there's been a steady movement recently to more of these pull rather than push supply chain designs over the years, just because of the sophistication that's been going on in information systems. Point of sales data, other data, information going back up the supply chain. Sometimes there are recyclables or returnables that go also back to suppliers. Particularly needs to be a green arrow to a supplier on that particular diagram right there. These are multi-tiered suppliers. This company makes the P-valve, this company makes the brakes, and this company actually assembles the brakes into the proportional valve. It's a critical part in a brake. If you don't have one in your brake, the brakes don't work. If your brakes don't work, you can't sell the car. Okay. And then, of course, we have a designer who designs to make the product inexpensively, and also makes it so it can sell. We want to be sure that we can sell the product. And then we coordinate everything, the flow of goods, the synchronization of the flow of goods, typically is with a third-party logistics provider, a 3PL. And this is often a company that is a trading company, or perhaps formerly a warehouse. This is the kind of end-to-end supply chains that I hope you kind of recognize. Now, the important thing, though, is what goes on here. These are manufacturing sub-assemblies and components. This does some manufacturing, but certainly assembly. But what goes on inside the factory is very important. The supply chain designer needs to understand the product that's being made, because there are ways of maybe taking advantage of the product in such a way to optimize the supply chain. So it's important to look at what goes on inside. For example, if you're making an oxygen concentrator, to understand the various sub-assemblies in the product, how the sub-assemblies are made, and even down to the sub-assembly level, where we would look at a flow diagram of a part, so that we understand a little more in depth what actually is being made in the supply chain. Okay, with that, there are a variety of different ways of moving goods. This is a fulfillment center at Amazon. These orange things are robots that lift up these shelves that move around, and there are more robots for the Kiva robots, for those of you who are familiar with them, and move around goods. There are more robots now than people in these fulfillment centers, and the ratio of robots to people is going up as you'd expect. This is a container ship that one of the real advances in logistics is the container and what it did for international trade. This is a line haul truck that might be familiar to some of you. I purposely tried to pull
the Greek one,
the Greek one, right? And this is a pickup and delivery truck that everybody is familiar with in the US at UPS. Rail, and this is air cargo. And I put this up specifically. You can't read it, unfortunately. It's Maersk Air Cargo. Maersk is a large container ocean shipping company that's now just recently started flying air cargo planes, because they're diversifying. They're becoming more vertically integrated in the way they work. And not all ways of moving goods are modern and so forth. There's a lot of
that's last mile logistics, right?
this is last mile. Those are the ships in the desert. Ships in the desert. Okay. All right. Well, why would an energy institute be interested in supply chains? Well, because they generate and use an awful lot of energy. If we look at the various sectors of where the sources and the end use sectors come from, transportation, of course, is passenger transportation as well as freight, but about 10% of this is freight, a little more than 10% actually. So it's a significant contributor to energy usage and energy consumption. Virtually all of industry will be in that category. So supply chains consume an enormous percentage of energy that we see used. And of course, we have residential and commercial down here as well. So that's a significant reason why there's interest. Now, in terms of modes of moving goods, because they do produce a great deal or consume a great deal of energy, there are rules of thumb in terms of what modes are most efficient in terms of energy usage. The truck delivers 83% of goods in the United States. All of you perhaps have had a truck, a straight truck, not necessarily a tractor trailer, pull up to your home and deliver something from Amazon and so forth. Probably nobody here has a railhead next to their house. Somebody has to deliver, or some mode has to do the delivering itself in the truck. 83% of the tonnage that's moved in the United States is moved by truck. In terms of energy consumption, if you put it in the air and fly it rather than truck it, you have a significant increase in energy consumption and greenhouse gas emissions. This is faster than trucks, of course. And so there's some advantage in speed. The advantage in speed is if the faster you can get things, the lower your inventory cost, because you can hold this on inventory in a supply chain. But if we go to other modes like rail, we get a 4 times decrease, roughly, is the rules of thumb of energy consumption. And then if you put it on the water, you get another big reduction in greenhouse gases and energy consumption. This is a slow mode, and faster as we go, less inventory as a result, lower inventory cost, and but higher energy costs. So there are trade-offs here. Okay, that's something about energy consumption. A little history of supply chains up until the pandemic. Actually, there was a relative stability in supply chains and demand. Not many disruptions. The disruptions were more local and regional, and as a result, we didn't have the impact that COVID brought to supply chains. And as a result, what we could do is minimize costs, focus on minimizing costs. We didn't have to worry too much about risk in supply chains, the kind of risk brings disruptions. Also, there's something called financialization, the term that I picked up from the section, where the boards, in terms of determining the compensation for executive officers, the CEO, would really focus on things they could measure, which are related to stock price. And that sort of increased the focus on minimizing cost. There wasn't much risk to worry about in this period of time. So we got executive compensation related to earnings per share, stock price, return on equity, short-term investor demand. So those are the activist investors who come in and raid the company. And why is outsourcing and offshoring of value from a cost point of view? Foreign suppliers have cheaper costs in the United States typically. Advanced IT and logistics lower logistics costs. In spite of the fact that it's made a long way away, the movement of those engines, say from China, Southeast China, to the assembly plants or engine plants in the United States, it's pretty cheap. So that's one of the reasons, the arguments for going ahead and making things offshore. Trade, bilateral and multilateral trade agreements were rampant before the pandemic. And that really opened up opportunities for the US in terms of making goods offshore, components and so forth. And there was a lot of subsidization of products, not only in China, all through Southeast Asia, primarily Southeast Asia, which lowered prices. And the result for us in the US was increased availability of cheaper goods. And the US consumer benefited from it. Since risk wasn't much of an issue or particularly dominant issue, we had lean supply chain. We leaned down cost. Anything we did not have extra manufacturing capacity. We didn't need it because demand was reasonably smooth. And these lean supply chains set us up for COVID, essentially. That's where we were when COVID hit. Well, let's talk about what can go wrong in the supply chain. And actually, the list would be shorter of what doesn't go wrong in the supply chain. Because you get suppliers, this is upstream, you get suppliers that can't deliver or they're suppliers and supplier plants. Production rate is slow, poor quality, demand can fluctuate. One of the things about demand for autos, say in Japan, was a very smooth demand, no matter what kind of economic environment they had. It helped Toyota develop the lean supply chain. Logistics, and can't find a truck to move goods. That's a problem. I should go back to demand for just a minute and say that during COVID, we not only had fluctuations, wild fluctuations in demand, like demand for autos, purchasing new autos dropped 97%. I mean, a huge drop, which meant that everybody who was making autos canceled all their semiconductor orders and so forth, which produced all kinds of other fluctuations. But also the demand moved geographically from hotspot to hotspot. So we had just sort of a perfect storm when it came to dealing with disruptions on the demand side. On the supply side, we had factories going down because they couldn't find workers, and we had because they're sick. We had lockdowns and so forth that contributed to that kind of problem. So throughout the supply chain globally, really what happened with COVID, it just got to everything in a supply chain. What are the causes? Well, we've mentioned, of course, pandemics, but geopolitical conflicts right now are kind of a major issue. Ukraine is a major issue. The China South Sea is a potential problem right now, and it's a real concern. But there are a lot of other things: extreme weather, trade wars, labor disputes, and so forth. Simple mistakes that occur. This is in Japan. This is a terrible slide to look at if you're a manager of the supply chain. And the result is increased lead time and variability. Lead time is the time between when you order it and when you get it, whether it's a component or a sub-assembly, whatever. You want that number to be short as possible, but also with as little variability as possible in order to make things work. Otherwise, you start missing customer service levels. Now, what's a customer service level? It's what the customer wants and when the customer wants it. And we'll get to what happens with customer service levels just on this slide. This is another goof that's never given in the Suez Canal. I couldn't quite get the nose of the ship, the bow of the ship in the picture. But just remind ourselves about a fact. Supply chains like predictability. And supply chains at this point, at the start of the pandemic, were primarily lean. Lean supply chains don't degrade gracefully when disrupted. I mentioned proportional valves in a brake. Toyota had a supplier, Aishiseki, that made 98% of its P valves. They had fire that completely reduced and dropped the production of P valves down to zero. Within 2 days, all of the assembly plants in Japan that Toyota had were shut down. Some of them were shutting down as early as 2 hours because how lean their supply chains were. Those same supply chains came up in about a week. Normally, it would take weeks to bring up the supply chains that they experienced. And the reason was a certain type of resiliency in the Toyota production system that we don't talk about very much, which is trust. The Keiretsu that Toyota is part of, they realized that Toyota was in trouble, and everybody started trying to figure out how to produce those P valves. Aishiseki started sharing the manufacturing design with companies that were not under contract to Toyota. And they just started making those valves because they trusted Toyota would make them whole afterwards, which Toyota did. And so that Keiretsu idea, that close partnership and relationship, turns out to be a form of resilience, something that is not appreciated in the auto industry in the United States very well. Okay, well, let's go back to, we've mentioned sources of disruptions, the ones that are of particular concern. Thank you. Are COVID, of course, extreme weather events. This is a little bit of a surprise to me, but I'll show you the chart in just a minute that indicates this. And of course, geopolitical risk, which, it's sort of interesting. Several months ago, maybe a year ago, people like myself who are interested in supply chains, we were interested in talking about, base stock policies and how to optimize supply chains with distribution demands and so forth. More recently, we're interested in the French election, South Sea Asia politics, and so forth. So geopolitical risks have all of a sudden become much more predominant. The implications of disruption. If you have a disrupted supply chain and you can't meet a customer service level, in other words, we owe you 100 units of this by this particular date, plus or minus 8 hours or so. It represents poor service, which means possible losing a customer. A rule of thumb, it's 3 times harder to get a new customer than it is to keep an old customer. So initially, what we saw was that when there was a disruption, companies did everything they could to meet customer service levels. A couple of months later, the bills started coming in, and we realized that these disruptions to satisfy customer service levels were starting to get expensive. As a matter of fact, this kind of disruption is created or has contributed a significant percentage of the inflation in the United States today. As a matter of fact, we have some lead economists saying it's produced the majority of the inflation that we see. Well, current trends move away from lean supply chains to these agile supply chains that are resilient to these shocks and disruptions, but at low cost. Figuring out how to balance the risk associated with disruptions at the same time taking into consideration costs. You never get away from a discussion of cost with the supply chain. So, question is, what's the best cost risk benefit? How do you come up with that cost risk benefit? And we'll get to that in a minute, a couple of slides. I wanted to show you something about extreme weather and how it's starting to affect supply chains. This is United States billion-dollar disaster events between 1980 to 2022 consumer product and CPI adjusted, okay? And you can see that we're starting to see this fairly significant impact. This is adjusted. This is not, inflation's been taken out of this adjustment. We don't see much in 2022 right now because we haven't seen all of 2022. And we certainly expect this to be up in this range here. So we're seeing the impact of weather on supply chains now much more significantly than we thought. I just looked at this maybe a couple of weeks ago and noticed this. I was surprised by it and realized just how much of an impact weather is having on just disruptions in general. Okay, well, let's get back to what's the best cost risk benefit. Well, let's back up a little bit more and say, what do supply chains, manufacturing supply chains in general have in common? A lot. They all have inventories. They usually have tiers of suppliers. They have distribution. They all have customers. So a lot in common. So there's a lot of commonality when you study supply chains, particularly in the same industry. If you're talking about auto and somebody from Hyundai is talking to somebody at Chrysler, they'll share the same jargon language. They'll all have engine plants. They'll all have distribution systems. They all have the same customer base and the same supplier base. So there's a lot of commonality, particularly in supply chains with the same industry. However, when you get right down to an individual supply chain and put it under the microscope, they're all different. They're all unique. And the uniqueness is that the balance of cost versus risk in designing the supply chain strategy is a function of the corporation strategy, what the corporation wants to do, and the product. You have a different kind of interest in making sure that customer service is fulfilled if you're selling a Bentley than if you're selling a less expensive car. And also management and the board's current perceptions. I have to say this because each corporate officer suite and each board has had different experiences. As Lectors mentioned, that I was on a corporate board of a Fortune 500 company. And we had a truck shed that was torn apart by a tornado in Joplin, Missouri. We never even thought about weather or tornadoes, but every board member after that, people would say, let's talk about risk. How about tornadoes? It just made a change in the way we talked. But the important thing is that I would take away here is the risk that a company and a supply chain is focused on is the risk to the company, to the firm, and to that product, not to the nation or the nation's public health, defense, or economic security. They tend to be almost orthogonal in some cases. And given that we've had, the COVID has pointed to the need to understand things at a global scale, a national scale in terms of risk due to disruptions. How do we align private sector supply chain risk with national security risk? That's the big question that's being asked right now in Washington, something that Lectors and I are very much involved with. And companies make their decisions independent of the national interest, yet critical industries and products are keep them. So we have a very interesting conundrum right now. That's much of the discussion what's going on in the Beltway. I think that's Houston. I don't know if somebody recognizes.
Because of the gas presence, right? That would make sense. Yeah, huge gas presence. Yeah.
Okay, how to prepare and mitigate disruption risk. A variety of different ways. First, way is to stockpile inventories. Inventories cost money, holding costs. Or also have extra manufacturing capacity around for surge once the components start coming back in. But that also is expensive. So stockpiles, the immediate crisis management scheme is something that is used, and was certainly used most of the time at the beginning of the pandemic, but really represent a lot of cost. Multiple suppliers, because supplier failure is fairly common through the pandemic. Have multiple suppliers that could, where one could pick up the demand, would have surge capacity if the other one wasn't able to work. This is a common way of dealing with supplier risk. Have your components designed so that if there is a failure of supplier, you can quickly share that component design with other suppliers that can rapidly start making that component. This is actually part of the resilience that Toyota saw during its P-valve. Aishinseki was making a very easily producible P-valve. They immediately shared the IP with everybody. A lot of companies went ahead and changed over and started making those P-valves, and that's turned out to be a major reason why Toyota was able to come back as fast as they could. Building an agile workforce and adaptive leadership is now a discussion in Harvard Business Review and other places. How do you come up with the kind of leadership that and a workforce that actually is able to adapt to various problems? Product designs and architectures that reduce lead times, postponement. Postponement is where you differentiate your product very late in the supply chain so that you can adjust to demand very easily and quickly. I'll give you some examples of that. It's a really great way of dealing with in an agile way. Concurrent product and supply chain design. This is something that's very important. I think it's the group that designs the supply chain needs to understand the product. The designer of the product needs to understand the implications to the supply chain so that they can come up with a product that's pretty good, but really good to produce. I have to go back to Toyota here as being really excellent at doing this. We've already mentioned trust in the supply chains and Toyota Keiretsu. It turns out there's more to that Keiretsu than I thought. I just looked it up a couple of recently, last couple of years. It turns out that all of these companies that are in this partnership own part of each other. And if you want to do a hostile type takeover of a company, and you try to go after a company in the Keiretsu, you have to please the rest of the Keiretsu because they own enough of the company to make a difference of 5%. And as a result, that's often what's called a poison pit when it comes to mergers and acquisitions. Conway had poison pills all through there. Something we do. Transshipment of inventory. Balancing inventory that is distributed, products and so forth is important to also be able to meet demand. Relocatable manufacturing capacity, 3D printers can do that. Also storage capacity. We'll see an example of storage capacity, which can be moved and reduce the CapEx for storage capacity. As a matter of fact, there's in Shenzhen, Shunfeng Express does this now in Shenzhen. Okay, move to more vertically integrated, decentralized supply chain structures. Great idea. That means you buy up your supplier base, essentially, your major critical suppliers. That takes CapEx though. So that's not an easy way to do things. Alliances are very better at it. And the Keiretsu idea is essentially kind of like an alliance, except everybody owns their own property. Smart trade policies, efficient and effective diplomacy. This just goes a long way. It's really nice to have friends. And at least we're comfortable with the alliances and the global diplomacy. And of course, it's as we go to automated systems, a little bit more cybersecurity. Okay. This is a load shift problem. By the way, it looks from other pictures that I found of this dog, it looks like this happened more than once. So he was just waiting to pull down. I don't think he was hurt at all. Okay, supply chain visibility. This is the ability to understand what's going on in various parts of your supply chain. Basically, when you're trying to control or coordinate or synchronize a supply chain, you need data. If you're managing a supply chain, in order to manage something, you need data, real-time data, with the objective of being able to balance this risk and cost issue that we've talked about. Data examples are current production rates, demand rates, and so forth. Lots of data that can come into a supply chain. Decision examples, adjusting production rates, transshipment, and so forth. Lots of decisions to make in a supply chain if you're controlling it in real time. And the more data you have, the more accurate it is, and the more recent it is. So the ideal is to get data transmission throughout the supply chain immediately without sensor and transmission delay. Never happens, but this is what we ideally would like. The reality is the data could be noise corrupted by poor sensors, poor communications transmissions, and delayed for a variety of different reasons. And some data may not be available at all. The reason, because that third tier supplier just doesn't want to tell you what the fourth tier suppliers are. For I almost said legitimate reasons. Yeah, sometimes they're legitimate, but sometimes they're not. So you just have to be aware of the reality of supply chains. Antiquated sensor, digital storage, and communication technologies, confidentiality protection, either legal or illegal, in some supply chains, and legal compliance in some cases, privacy compliance. The long and short of it is complete end-to-end supply chain visibility is difficult, no matter what your supplier base is. General Motors has over 18,000 second-tier suppliers. Just keeping up with your supplier base is a huge challenge for durable goods manufacturing in general. Let's talk about next generation. Now we're starting to talk about the dream. Okay, what we'd like to see, the ideal. Visibility, first and foremost. Agility, clearly that would be great, so that you know when there's something going on, and you know what to do once it goes wrong, and you can adjust. Real-time decision-making based on real-time data. That's the ideal sort of situation, and that might require some data analytics that are next generations. Reinforcement learning, machine learning, some of those AI-based ideas blended with operations research and statistics to come up with a really effective way of extracting value out of data, monetizing data. That's really what we're interested in. Reconfigurable supply chains or relocatable manufacturing and storage capacity. Here is TNT in Brussels. That storage, portable storage element moves a couple of times a week because of different demands in different parts of the city. And it saves, instead of having two stores with this capacity, they have one van. So they're saving money. CapEx and also they have a lot more flexibility because they could take that to another city if they wanted to, if they needed to. This is a 3D printer, depending on how big the printer is. You know, some of these 3D printers, metallic printers, are pretty big, but most of them can be put in a 20-foot container, a TEU, so they can be moved. The same thing is true of pharmaceutical manufacturing. As a matter of fact, it's a technique that a lot of pharmaceutical manufacturers are using right now to have portable modular production facilities. Okay, distributed supply chains, if they're distributed, and all of a sudden one particular area of the country, the world, has an increase in demand, if you can move your manufacturing capacity, then you can all of a sudden turn that area into a area that's still meeting customer service levels. You take productivity and production away from other areas, but you may not need it. So if you can adjust maybe the overall effect, because you're risk sharing, it's called risk sharing, you can reduce your total capital expenditures. So this is something that we found is really quite an interesting tool, which is relocatable manufacturing capacity. That would essentially let your network be lean or agile, depending on what you need, at least in parts locally, not everywhere. Some other routing and scheduling ideas, if you can anticipate pickups, like pickup and delivery for LTL and package express, 70% of the time, you know that this particular industry or company is going to ask for an order. 70% of the time, those orders come in at the same date for the request. Why not just move your vehicle, pick up and delivery vehicle that way, knowing that it's likely to get a call and it can divert off and reduce the amount of greenhouse gases produced, as a matter of fact, and also reduce the cost in the supply chain. Dynamic stop sequencing based on real-time traffic data. Right now, everybody knows what the traveling salesman problem is here. Some of you, yes. Okay. Okay, and let me kind of remind you what it is, okay? You're told before you leave the facility that you're to go to A, then to B, then to C, then to D, and so forth. Well, what if you go to A, then you see what traffic congestion is and say, maybe it's better to go to C first, and then look at traffic congestion and go to D, and then back to B, and so forth. Route on the basis of traffic information congestion. The pickup and delivery vehicles in Tokyo do this manually, as for a variety of reasons, it's manual, not otherwise. But there's a significant savings in that information and using a dynamic warehouse. So let's talk about flow. This is something that's that we're sort of busy with. I'm noticing the time is kind of my short. Basically, we recall we have for a single supply chain, Indian visibility is tough. Who cares about the other supply chains? You know, General Motors. If you ask General Motors, what do you know about Delta's supply chain? You're going to find one. You know, it's not of interest. Yet, if we have a pandemic or something, a national crisis, it would be nice to have a global decision maker that knows, has visibility across the supply chains. And that's what flow is intended to do. It's voluntary, secure national freight data exchange. And the intent is to balance supply and demand over the infrastructure being ports, roads, rail, and so forth. And there's a test going on right now to see how well this idea can better align private sector interests and the nation's interests. And a lot of participants involved, not enough, but at least there's good representation. And we're able to stay there, more representation. The value of flow data, we don't know. We don't know really what it is. Is the additional data that a company would get out of this idea useful, valuable? What's in it for me? Right? That's a private sector concern. And what's the risk of data sharing? Is the value of data sharing negative? If you have a partially observed two-agent non-cooperative sequential game, okay, where the observation quality improves for both agents, are there winners and losers? We happen to have an expert for that kind of model in the room here. Centralized decision-making, open questions. Who decides who decides? We don't know yet. This is a developing idea. And if there are winners and losers, how do you compensate the losers so the losers don't drop out and attract the negative things? So lots of questions going on about this at the national level right now. There's a report coming out later this month on this on the White House. Next generation ecosystems, agility, resiliency, and efficiency. This is the example that I won't really, because we're running out of time. But it's a way of developing an infrastructure and investing that has private sector interests in mind as well as public sector interests in mind. It's a very specific example, but we will just stop there. And thank you very much for